Today we're going to be reviewing different types of functions and then transformations of functions. So there's a bunch of different basic functions from Algebra 1, and these are kind of the graphs of them. These are the parent functions, aka the function before it's been moved or other numbers added in there. The first one right here, it looks like a line. It is a linear function. Your parent equation is y equals x. And then we can move that around in slope-intercept form and different things, but that is a linear function. The next one is a quadratic. The shape of the graph is a parabola. And all of those equations have a highest degree of x squared. The next one looks like quadratic, but it's a V shape instead. So this one is going to be your absolute value. I remember this one because the V in value looks exactly like the graph does. So then this one here, you get y equals the absolute value of x. That's again before moving all around. That's your parent function equation. The next one here is exponential. It looks like a slide. And normally it's y equals b to the x, where b is your base. This specific one, my base here is 2, so it's y equals 2 to the x. This one, your x is your exponent. That's what makes it exponential in your equation. The next one is called square root. It looks like half of a parabola turned sideways. It is y equals the square root of x would be your equation for that one. So in Algebra 1, you graphed all of these different types of functions, and then you started moving them all around and stretching them. You also were asked for domain and your range for all of these. So looking at this, just a quick recap of domain and range. Domain and range, domain is your x values. So it's what values do you see on your graph, or what values can you plug into your equation. You're always going to go left to right. Whereas your range, I think of a mountain range, that's my up and down. Those are going to be my y values. Domain is your inputs, range is your outputs, your y values. You're always going to go least to greatest, which in this case is low to high. And for both of these, we're going to write things in interval notation. So in interval notation, we're going to use parentheses if something gets close to a number or a value, but never touches it. You might see this in the exponential. You'd have an asymptote. It's going to get closer and closer to that number, but never actually touch it. You're always going to use parentheses with infinity as well, because we can never fully grasp that. It's always going to be that parentheses there. It gets close to it, but can never actually get there. Versus the bracket. The bracket is when you actually get to a value, or when it actually touches a value. This means it's included in the domain or the range. Okay? So your intercepts, as a quick reminder, you're going to have x and y intercepts. Some graphs will not have x intercepts or y intercepts depending on the graph, but there's a potential to have more than one as well. So your x-intercept is when you have some number for x, but your y value is 0, because your x-intercepts here are going to be on your x-axis. So it's going to be some number, comma 0. Versus your y-intercept, that would be on your y-axis, which means the x value is 0, but your y value is some number. So 0, comma, some number. So what we can do is we can take graphs and equations, and we can start moving them all around. So what we're going to do is we're going to move a square root function all around. So really quickly, to graph the square root function a little bit nicer, you can kind of think of what numbers are nice to square root. So x comma y, we can plug in 0, 1, 4, and 9. Those are numbers that are nice to square root. When you do that, you get 0, 1, 2, and 3. What's the square root of 0? It is 0. What's the square root of 1? It is 1. What's the square root of 2? Well, it's not a nice number, so we jump all the way to 4. The square root of 4 is 2, and the square root of 9 is 3. That's what makes the shape of this graph look like this. So this is your parent function, y equals the square root of x. So the very first one here, we have y equals negative square root of x. This negative sign out in front is going to reflect things over your y-axis. So it's reflecting everything over the y-axis. In essence, this is changing your y values, not your x values. So 0, 0 stays where it is. 1, 1 is going to get reflected down, and now it's going to be down here at 1, negative 1. 4, 2 becomes 4, negative 2, and 9, 3 becomes 9, negative 3. So this graph down here is y equals negative square root of x. Y equals the square root of negative x. This negative on the inside affects your input. So it's going to affect your x values. This is going to reflect over the x-axis. So it changes the x values instead of the y values. So 0, 0 stays. 1, 1 becomes negative 1, 1. So imagine, if you will, plug in negative 1 for x. So if you plug in negative 1, you're actually taking the square root of positive 1. That's why it works that way. So 4, 2 becomes negative 4, 2. And 9, 3 becomes negative 9, 3. And so now the arrow would be pointing to the left for forever. So this is y equals the square root of negative x. Okay, so let's go ahead and take a look at the next one. We have y equals the square root of x plus 3. You notice that the square root of x ends here. This is afterwards. This is your k value. So this here is going to move your graph up 3. So this affects y values. It doesn't change the numbers you're plugging in. It just changes your y values, aka how far up and down they're going. So we're going to take all of our original numbers for our original graph and move each of these points up 3. So 1, 2, 3. Or you can plug in 0, 1, 4, and 9 into your equation and see what you get out, and you'll notice it just moves all those up 3. Okay, let's go ahead and do it inside the square root now. So notice this minus 2 is inside, so it's going to affect your inputs. And so this one here, this minus 2, is going to do the opposite of what you think it's supposed to do. So this one here is going to move this graph right by 2. Inside affects the inputs, and it does the inverse of what you think it should. So I'm going to take my function y equals the square root of x. I had that in black over here, and I'm going to move each of those points right 2. So 0, 0 becomes 2, 0. 1, 1 becomes 3, 1. And I'm just going to move each of those points right 2. So this is y equals the square root of x minus 2 in parentheses. So now I'm going to throw a 4 out in front. This is your a value. This is your vertical stretch. So this is going to be a vertical stretch of 4. This is going to affect your y values, not your x values. So basically each point is going to get 4 times as tall or as far away from the x-axis as it was. So our first one is still 0, 0. The next one was 1, 1. So that 1 is going to get stretched out 4 times taller. 4, 2, the 2 is going to get stretched out 4 times taller. And the 3 also would get stretched out 4 times taller. So this is y equals 4 times the square root of x. And then our last one here, let's see, the 1/2 is still the same idea, but it's a vertical compression of 1/2. And so 0, 0 stays the same. 0, 1, your height here gets shrunk in half. 4, 2, the height gets shrunk in half. So it's at 1. And again with the next one. So it's a vertical compression. So this is y equals 1/2 the square root of x. So a lot of these affected your y values. The only ones that affected the x values were inside the radical. Everything else affected your y values. So let's take a look at another one. So this graph would be a quadratic. So just a very quick visualization. Here's what your normal quadratic looks like. Again, very rough sketch. So now we want to see what all of these different things do to your graph. You know what, let's go ahead and move this so we can kind of write over here a little bit better. There we go. So this -1 is on the inside. So you're always going to do the inside part first. So the -1 would move everything right 1. The -2 is going to do two different things. The minus sign out in front is a vertical reflection. I'm not going to call it vertical reflection. I'm going to say reflection over the x-axis. The ×2 is going to be a vertical stretch of 2. And then the +3 is also still going to be affecting your y values. That's going to move your graph up 3. And so when we list this, what we're going to do is we're going to kind of list what it does to the x's and what it does to the y's. And normally you do the x's first. So the x's are going to be moved right 1. The y's are reflected over the x-axis with a vertical stretch of 2. And then it's going to be moved up 3. So if you're kind of someone who's kind of moving this around in your head, that's the order you do it in. Whatever's with the exit, then whatever it's being multiplied out in front, the a value, and then the plus k, the up and down goes last. So we're going to move everything right 1, flip it over, stretch it, and move it up. So visually, it should look something like this. Okay, thank you very much for listening.